Hello, my lovelies. Welcome back to Chapter 4 and our investigation of how banks work in Mathland, because I don't think any of them work like this in reality. So we're going to pretend this thing called a savings account exists. And what it does is you put money in it every month, and then interest compounds on it every month. And what we're going to look at is, if I make this payment for this long at this rate, how much is the accumulated balance going to be at the end of whatever time I set? So the fantasy part here is finding rates like this. I just looked at my bank and it was 0.05% as an APR, which, yeah. But that's a political thing, so moving on. So we have crazy looking formula. Example, use the savings plan formula to calculate the balance after 6 months for an APR of 12% and monthly payments of $100. Ooh. All right. So using our formula there. So the monthly payments are going to be $100 times crazy big fraction. All right, so our APR is 12%, so that's 0.12 as a decimal. And then N is the number of compounding periods per year. So this is one of my problems with this problem. It doesn't tell you that it's going to be compounded every month. It just assumes that you would assume that because you're making monthly payments. But on all of these, whatever regularity you're making the payments in, that's what we're going to assume it compounds in. And I think they're all monthly. So we have 0.12 divided by 12, because that's how it would be apportioned. All right. And then, okay. That inside one is raised to the NT. Okay. Couple of ways to think through NT here. So the number of compounding periods per year is 12. And the number of years here, though, it said after 6 months. So that's a half a year. So we're going to have 12 times a half, which is 6. The 6 compounding periods, the 6 months. Normally it's after so many years. This one's just being weird. All right, so there is the top of the ridiculous fraction, and then on the bottom, we have the same 0.12 over 12. Which actually works out nicely, it's 0.01. All righty, so now we get to crunch this insanity. So I'm just going to use the handy dandy in-app calculator. Yep, there's the 0.01. All right, now we're going to type some of that craziness. 1 plus 0.01 close to the 6th. And then I'm going to sneak back to the beginning, put the extra set of parentheses around that, minus 1. All right, so 0.0615. So that's the top of our fraction. We still need to divide it by the 0.01. $6.15. And then we multiply that by 100 and we get 615, but I'll type it. So after 6 months with an APR of 12%, we will have $615. So in half a year, our $100 payments made a total of $15. Right, so like I said, Mathland. So we're just going to do this over and over and over again. So there's like 4 or 5 examples coming up. And then towards the end of the section, it starts talking about stocks and bonds. And well, given how this problem went, I'm not sure how accurate it's going to be. But since they're doing so many examples of this, this is a good question to put on the test. Speaking of, you guys do have a test next week. I'm going to put the test review out later tonight or tomorrow. Scratch that. You guys will watch this tomorrow, so I'm going to put it out on Thursday. All right, here. At age 30, you start an IRA to save for retirement. You deposit $100 at the end of each month. You can count on an APR of 6%. How much will you have when you retire 35 years later at age 65? Okay. Can't even say this with a straight face. So going off that same formula, we still have the $100. One plus our APR is 0.06. We're going to have that over 12. And then on the bottom, we're going to have the same 0.06 over 12. And we know there's a -1 there, so we just need that power. So that is 12 times per year times 35 years. So the assumption is this would get really big. I don't think it will. All right. So let's go ahead and crunch some stuff. So 0.06 divided by 12. 0.005. Yeah. Let me just move that. All right. So now we are going to have, you know what, I'm just going to type the whole thing. All right, 100 times, open, 1 plus 0.005 is 0.005. So we can save ourselves a little bit of work. Raised to the, and then because there's 2 numbers here, I'm going to open parentheses. Or you could calculate 12 times 35 separately and then just put whatever that result is there. Then we subtract 1 from that. That is all of our top things divided by the bottom thing, which was the 0.005. So we'd round that to 0.03. So 142,471. I'm curious. Yeah. So it's 420 compounding periods times $100 is $42,000. So that made another 100,000 on top of that. Yeah. All right. Now they're going to talk about a college fund. Like, these problems were actually written a couple years ago. Even then, they're still poorly chosen, and I apologize. Yeah. So we want to build a college fund of $100,000 in 18 years by making regular end-of-month deposits. There's something about end of month with savings plans, like whatever's in there at the end of the month is what gets accrued on at the beginning of the month, like the next day. That's why it's going to keep saying that, but otherwise, meh. Assume an APR of now 3%, but we're depositing more, $250 per month. Will you make your goal? What about 350? I'm going to bet the answer to the first one's no, because they said, what about 350? Okay, so the 100,000 is our end goal. So in the formula, that goes in the A position. They did tell us our payment. In fact, I don't think we actually need to put that in right now. That's just what we're going to compare against at the end of the problem. So right now we're going to see, is 250 enough of a payment? 1 plus, now it's 0.03 over 12, which will be half again as small as the 0.005, so it's going to be 0.0025. And we have 12 times 18 is that power. Don't forget the -1. And that is all over our same 0.03 over 12. All right. So let's see if we can't crunch this insanity. So let's figure out the little interest rate part. Yep, see the 0.0025, half of what we had before. So now we will take our payment amount, 250, times, open two parentheses, then 1.0025. We're going to raise that to the open it so it keeps it all together. 12 times 18. And then we will subtract 1. And then we are going to divide that by 0.0025. Yep, not enough. We get 71,485. And that was even putting in a good amount. I mean, you're looking at 3,000 a year. Through the magic of copy paste, or on a lot of the fancy computers, on the calculators, wherever you hit equals, at least on the graphing calculators, if you hit second and then that, it's entry, and it'll recopy whatever the last line was, and then you can move the cursor around and change numbers. You just have to be careful because sometimes it just does a straight overwrite and sometimes it'll move everything. But here we just want to change the 2 to a 3. Nope, sorry, 350. There we go. 350 is just barely the minimum, apparently. Just over 100,000. That is so ridiculous. Now, what I started to do, we could actually back solve to figure out the exact payment that would get you exactly 100,000 and like a tiny bit of change. But 350 is probably the first nice number that ends in a 0 that works. So here, now it's a savings account with 4.5% interest, and we're depositing the 250 at the end of each month. How much money will you have after 15 years? Yes, because we all have $250 after we pay our bills to put in savings, of course. All right. So 0.045 divided by 12. I'm not sure if this has, it only shows so many decimals, so. It's actually 0.00375. That's just a flaw of me using Outlook as a calculator. It's not actually a good thing for a calculator. All right, so our payments are 250. Inside 1 plus the ridiculous decimal. $12 times per month times only 15 years. Minus 1. And then divide that by 0.00375. We will have $64,103 and probably just 66 cents, but 66 or 67, it should take either answer. Still, after 15 years, that's not that much. Oh, yeah, this is. Okay, you need to save $800,000 in order to have a comfortable retirement. If you can count on an APR of 9% and you have 30 years to save money, what should your monthly payments be in order to reach your goal? So now we're going to do the back solving that I was referencing earlier. So that 800,000 is going to go there. And then we're going to have our unknown PMT. And now the rest of it, we still fill in like normal. So our two opens, 1 plus 0.09 over 12. And this will be raised to the 12 times 30, which is going to be a whopping 360. Then minus the 1 all over the 0.09 over 12. All right, let's see what we get. So 0.09 divided by 12, 0.0075. I know 9/12 is 3/4, which is 0.75, so I was expecting something around there. All right, so a couple of ways to go about this. But all this stuff on the right here after payment, that is all number crunch calculations. I can calculate that out and get a number that goes in that position. The only catch is if I calculate that number and it's rounded, then when I solve and get payment by itself, the rounding due to 800,000 being so big might make the answer a little bit off. Now I try when I do tests to make sure to take that into account, but just in case, you got to be a little careful. All right, so we're going to crunch that number. 1.0075 to the 12 times 30 minus 1 and close it, divided by 0.0075. All right, so all that junk on the right comes out to 1,830 and change. So let me zoom in so my handwriting isn't as horrible, hopefully. So we have 800,000 equals our payment times that number we just got. So this is an equation with one unknown. I can solve for the unknown. I just have to use some math manipulation. And I have to do the same thing to both sides. I have to preserve the balance of the equation. This is telling me right now those two sides are equal. I can do whatever I want to the two sides as long as it's the same thing. and you don't divide by 0. So here, payment times 1830, blah, blah, blah. I want to get rid of that times the number. So to cancel out multiplying, we're going to divide by that number on both sides. So the 1830 point blah, blah, blah cancels. And then we will type the whole thing that we at least got when we calculate this side. All right. Why must I have that open? Okay. And through the magic of copy paste, hopefully, we have 800,000 divided by paste. Don't need to close the parentheses, there are none. So $436.98. So we could call it that. It's 2 cents off from 437. So wouldn't be a bad idea to round it up just to be sure. But I'd take 436.98, I'd take 437. I might even take 440 if you made an argument for it. Okay, so we all got to go out and find that APR of 9%. When you find it, please let me know, because I'm pretty sure it doesn't exist. All right, I'm going to stop this one and then come back with the total things.